Attendees are in listen-only mode.
Hi, good morning or good afternoon everyone, and welcome to this webinar on the Seismic Data Management, or SDM, from Cegal. In this webinar we want to present this concept of modern seismic data management and highlight some of the key areas where the SDM fits well with this topic. So the three areas I want to focus on are the automated scanning and cataloging of the SDM. Next, how the SDM really streamlines loading and quality control of seismic, and finally then show some of the processing tools which are within the SDM. We then want to have a quick recap of what's in the most recent release of the SDM and have a little bit of a look forward to the future releases, and then do a live demo of some of those new features and improvements. To start with here, just a quick comment on how to work with this meeting. We're using GoToMeeting, and you can open and close your panel using the orange icon to get some more screen real estate. You can also switch between full screen or windowed. By default, everyone's muted, but we do have the possibilities to take questions at the end, and there's a box on the GoToMeeting panel where you can enter questions, comments, or if you want us to show something in a bit more detail. I'll take some time at the end to cover questions and extended demo, and we'll also send a recording of this presentation out to everyone that attends within 24 hours. So firstly, I'd like to say, who is SDM for? Well, really it's for data managers, geophysicists, and anyone working with seismic data. And the SDM is a modern data management platform which uses automated scanning to streamline data quality control and loading. Just a quick little bit of background on the SDM. The SDM is Cegal's first standalone application, so it's not developed on this ocean platform as all their previous software has been. It's entirely web-based, so everything runs through the browser, which makes it a really nice, easy-to-use tool. And in addition, it is integrated with Petrel, so we do offer some level of integration with Petrel and ZGY scanning. In the SDM, really, there's something for everyone. The main purpose is really to build up a database of scanned and quality-checked seismic, which give you a full insight into the data sets, the surveys, all the normal metadata you associate with seismic data, like the episodic and binary header, as well as building up this more detailed library of knowledge and scan parameters. And that's really one of the main purposes of the SDM, to obtain these scan parameters which are required to load seismic data into applications. So whenever you're going to do the loading process, you've already got this record of how that data should be handled. In addition, for browsing purposes, you have a really nice fast loading map with the ability to define additional layers as web map services. So this makes the SDM a nice foundation of a GIS system for your seismic data, which can also be further integrated with other GIS systems that you have. We also have a set of processing tools which are really for fixing small problems in the data or conditioning data before loading to application. So something like the cut seismic, which is used to crop down bigger surveys into smaller area of interest. To further streamline loading, we also have this loading companion for Petrel, which can link the seismic files and the scan parameters that you have in the SDM and just pull the data sets directly into Petrel and speed up the loading process. So now we want to move into these three topics which we think make the SDM a modern solution, and the first of which is the automated scanning and cataloging process. So at the heart of the SDM, there's really a sophisticated automation engine which uses a library of templates, SegWy templates, that are provided with the SDM, and also have the possibility to define your own user templates. And the automatic scanner uses this library of templates to go through the data sets, figure out how these data sets need to be parameterized in order to load correctly to the applications. So what it does is it reads through the files, and it first of all determines the file type based on the headers of the file, if it's 2D, 3D, or pre-stack. It then determines the loading parameters for this data by using pattern recognition, which assesses how the traces are organized. So if the traces have a nice linear increase, it's a 2D line, and if it has a stepwise organization, it's a 3D cube. It then determines some further information about the seismic, like the shock point ranges, inline crossline ranges, and the amplitude ranges of the data, which provide more information. It checks that the seismic is within the CRS that you have chosen for it and adds it to the map. It checks the continuity of the traces and identifies any subsections if you have them. So if a 2D line has a break in the shock points, it will identify that and then calculates the amplitude ranges. So with seismic data, the devil is often in the detail. And here we outline a few more of the things that the autoscanner does to help extract as much information as possible in a very easy way. So as I mentioned, it automatically detects the type of seismic or navigation files that you're working with. We have a way of automatically linking datasets to surveys and also category or vintage based on the folder structure. So this means if you have already a kind of good organization to your seismic data, we can use the folder structure to group datasets to surveys and into vintages. As I mentioned, we also have these options to scan the data, so you can rely upon the automatic scanner, which uses the library of predefined templates, but you also have the possibility to define your own templates for scanning some datasets which may have a peculiar setup. The SDM also automatically detects duplicate files. It will give you a nice clean catalog of the unique seismic datasets, but keep a record of where these are duplicated on your file system. In addition, we can also collect additional metadata from the folder structure, as I mentioned, but also from the episodic header. So we can use something called regular expressions to extract the survey, the dataset name, category, and also the coordinate reference system. Once datasets have been scanned, it's then possible to browse them in the catalog here, which is a sort of tabular view into the data. And this gives you information about the datasets, the metadata, and also the other attributes that the SDM collects and calculates about the data. Once scanned, the data is also available in our map, where you can get an overview of your datasets, navigation data, and also further integrate it with other GIS layers. As I mentioned, there's quite a lot of detail to what the SDM collects. So first of all, you get the basic metadata like the episodic and binary header, but you also get more calculated values like the inline crossline ranges, shock point ranges, and amplitude ranges of the data, which help you with the quality control. Adding more knowledge to the datasets is also a kind of focus area of the SDM. And we have the ability to define surveys in a lot of detail, include a lot of additional attributes for surveys, and also attach documents like processing reports to the surveys. So in this way you can kind of enrich the knowledge that's there about the datasets, where they come from, and if there are any more newer datasets associated with the same survey. There's also a few areas of data validation that the autoscanner will collect for you. This is, for example, like the spatial information, which will validate the data within the coordinate system that you think it is, and also the seismic subsections, which will outline any breaks in your shock points of your 2D data. The next part where we think the SDM is a modern solution is related to loading and quality control of seismic data. So first I'd like to present this diagram where in the upper part above the line, we show the traditional workflow for loading seismic data. So when you need to load a seismic data set to an application, you typically need to use some sort of utility to interrogate the header to find parameters, copy these parameters over to a loader where you then do some sort of validation. You then proceed with the loading to application, and after which you then can quality control. If you find some sort of mistake in the header and you put in the parameters wrong, you then have to go all the way back to the start here, and this sort of becomes a trial and error process when the data is not as it should be. In addition, whenever you load to different applications, you need to repeat this process each time, going back to the header and going through the steps again. So with the SDM, this process is really streamlined again through our use of automation. So here in the SDM, the first 3 steps, they're really handled by the automatic scanner. So the auto scanner will go to the headers, check the parameters, and do some validation to figure out the correct loading parameters of the data. And all you then need to do as a user is just copy those parameters into your loader, or in the case of Petrel, we provide a plugin to do that for you. So this is where we really think the SDM can streamline the loading process and save a lot of this trial and error, frustrating problems when you don't get the right information from the headers. In this process, there's also the issue of quality control of the data, and with the SDM, this is also something that's partially automated. So as I've mentioned, the SDM collects certain parameters and calculates certain values which can help with a little bit of pre-loading quality control of your data. So here we can see some of the ways in which this process is streamlined. For the quality control, of course, we have the map. So the positioning of seismic data is probably the most important quality control step. You know, it absolutely has to be in the right spot. And once you've got the positioning of your survey correct, it's usually not a problem to then get the traces loaded in addition. So firstly, you have the map to QC, you've got the positioning correct, and then you have some information on the amplitude ranges, the shot point ranges, etc., which can be used as a further quality control. In the middle here, we have the scan parameters, and this is really the heart of the SDM, or really what we want to extract automatically. And these are the precise parameters needed to load this data set to any application. So with the SDM, you don't really need to interrogate the files in the same way. You let the autoscanner do that, and as a user, you just copy these parameters and away you go. We also mentioned this Petrel plugin where we can load data directly, so I'll show that a little bit later on. And this plugin will also have a way of doing a little bit of QC of the seismic data that's in Petrel and comparing with what's in the SDM. The final element to mention is also these processing tools that we have, which are really a set of tools to firstly correct problems in the data or condition data before loading to application, for example, the cut seismic. So just a couple examples of what we've got. We have the split 2D line, which will convert lines which have a split in the shot points into 2 separate objects so they can be dealt with easier. The trace header allows you to modify values of the trace headers using expressions. Cut seismic is more a conditioning step to crop down large surveys into smaller areas. Navigation merge, which overwrites the coordinates of 2D lines using navigation files. And of course the delete from disk, which can help you with the cleanup of the duplicate data as identified by the SDM. So here's a quick example of the cut seismic in action. I've made here what's called a file collection, which is just a shopping cart of a number of different angle stacks from a particular survey, and I'll pass this into the cut seismic tool together with a polygon that I've drawn on the map, or I can enter coordinates if I want to. I run that and I then get 3 new cubes which are ready to be loaded to the application. So before jumping into the live demo, I wanted to mention a couple of the new features and recent updates in the SDM. Firstly, back in December, we added a lot of new attributes for surveys and also included survey events to really enrich the information when you create these surveys in the SDM. We added some new processing tools like the export trace headers, and we also had quite a lot of improvements to the map, particularly the performance of the base map and performance of the web map layers. In March, we added some more things related to the surveys, basically the ability to attach processing reports or other documents to your surveys. And we also included a ZGY scanning plugin for Petrel so that you can do all the mapping and cataloging of ZGYs in the same way as you can with SegWy. Coming up this summer, we're releasing the loading plugin for Petrel to pull data directly from the SDM using the loading parameters into Petrel, and also a loader for loading surveys from the NPD, which is a thing for Norwegian-based companies. So now I'd like to take you through those new features as well as a sort of brief intro to the SDM. So here I have my SDM dashboard, which is a typical entry point into the SDM, and you can see where you have recently scanned data and get an overview of the amount of data that you have. Next, I'm going to move over to the catalog, which is the main tool for browsing data in the SDM. So here I can see my scanned data sets. I can filter a lot of this information here by survey, for example. And as I browse over, I can change the view here to be relevant for 2D data or for 3D data, and it will show me the different columns for this data. I can also filter for any of the values that I have, but we've also now included the ability to use this free text search, which is basically using both the name, the path, and the episodic header of all the files to provide a really quick and easy way of filtering data sets in the SDM. A small improvement we made as well is the ability to reorganize the columns and customize the columns that you want, and it will keep that state until you choose to reset back to the default examples here. If I click on a particular data set, I can also open up the details menu here where we start to get a lot more additional information about these data sets. So here we have the episodic header and the binary header. Then we have some kind of general information about the data, the CRS, etc. And most importantly, we have these SegWy scan parameters, which are the required parameters to scan or open up this data set in an application. We also have here the file instances, which is a list of all the instances of this file, which will show more than one if we have a duplicate of this particular file. In addition to this, there's also some other catalogs here. We have the seismic file catalog, the navigation catalog for nav files with their own details as well. And then you have the instance catalog, which is all of the files regardless if they're duplicate or not. So one thing I wanted to show now is some of the more detailed information for QC. So you have here, for example, the inline cross-line ranges of this data set. You also have in the catalog the ranges and the amplitude range of this particular data set as well, which again can help with the QC. And for 2D data, if there's any subsections, you have this identified here. Next, I would like to show you the map, which I can open up by opening in a new window, like so. So the map is basically for browsing data, and I can here also define any additional layers that I want. So I've got some web map services defined here, and I can choose whether I want them on by default or not. So here we can see my data. You can also bring up the details for the datasets in the map as you could in the catalog. And it's also possible to work with these two windows in parallel here. So I could, for example, select some data on the map, add it to my selection here, and use that as a filter in my catalog. And there's also some cursor tracking there between the map and the catalog. The other function the map provides is the way to define a polygon for cutting seismic. So here I can draw a polygon, which is my new area of interest, save that, and that will become a polygon I can use later for the cut seismic process. I then would like to show you a couple of the new advanced features in the scanning and crawling of data. So first of all, in the crawl, you see that we have some new options now for including ZGYs, both external and internal, in Petrel project directories. And you also have the possibility to include documents in the scanning. So this will link any documents that it finds on the same file level as the seismic data and link them together in the SDM. When you're running the full scan mode, the same thing applies. We've got the option here to run for Segway and navigation scanning, which will run the full SDM autoscanner. Or we also have the possibility to run ZGY scanning mode, which will run Petrel in the background and load the ZGY datasets into Petrel and pass the relevant information back to the SDM. As I mentioned, one of the key points of SDM is trying to extract as much information from the data as possible in an automatic way. So we've added now a few options to help with that. So for things like the survey name and the category, which is basically vintage, and also the coordinate reference system, we can use what are known as regular expressions to extract that information from the header. So I'd like to show a quick example of that. So here I have in this regular expressions tool here a typical string or text from an episodic header, and there's obviously a lot of useful information in there, but it's all text and it's not necessarily always the same organization. So here is just a simple expression which can match the word survey with a colon and then extract the preceding word after that. So you see on the right hand side here, it's possible for me to extract this survey name automatically by using this string matching process. So that's indeed exactly what we can do for survey names, for vintage and for CRS, or these can be defined manually through your defined surveys or extracted from the folder level here. So if you have a well organized set of data, you can extract that already automatically. Next, a couple of things to mention in the processing tools. So here we have, for example, the cut seismic, where we've added a lot of new features here. So we have the possibility to choose a file collection, which is a collection of seismic files, and then specify my polygon, and it will run cut seismic on all the files in this collection and make new data that's ready to import to applications. Next, something to show from the more administrative side. In the configuration, under surveys, we have the ability to define new surveys, and if I choose to edit an existing survey, you can see here, this is where I can add more detailed information about each survey, like the country, area, the acquisition company, and if you have any survey events like reprocessing that's happened, you can record this here. And here's where you could also update documents as a post-process to the surveys in the SDM. So if a document's not included at the time of scanning, you can add it later. Next, I want to cover the administration module, which has just a new tab to define a Petrel instance, which is used for scanning of the ZGYs. So you define here a Petrel executable and a license path, and it will run that in the background for the ZGY scanning. One last question before I move on to the loading plugin was this morning we had a question about how this works between user and admin mode. So here I'm showing you the SDM as a full administrator mode, which has all these modules, but it's also possible to run with the read-only user, and there just get the dashboard catalog and the map. So there's two ways which the SDM can be run. So for the final part of the demo, I would like to show you the loading plugin for Petrel. And what you're required to do in order to make that work is to first of all create here a file collection, which is just a selection of data sets that you've made in the SDM. Then I will switch over to Petrel and show how that works. So from my Marina here, I can choose the SDM data connector, and this will bring up a plugin window. It's then connected to my SDM through a web URL, and it will list the data sets or the file collections that I've got here. So I'm going to choose this particular file collection, which contains this 5 2D lines and validates that I've got permission to load them. So I can select all, click next, and then what I have to do is basically choose some additional options for loading. Do I want to use an existing survey, or in this case I want to create a new one, and vintage if I want to use existing vintage, or indeed create a new one here. So I'm going to create a new one called time 1. And then I just press import here, and this tool will start to load these data sets in. So here we can see how the SDM has really streamlined the process for loading data, in particular 2D data, which can have a lot of trial and error work for loading different data sets. So here I've got my 2D data now loaded. I can just show it here like so, and the wells tell me that it's loaded in the right spot, and I can also just open up an interpretation window to visualize that there. So loading 2D data has really never been easier with the SDM. So now I'd like to just have a few closing remarks about the SDM, and then I'll open up for questions and further demo. So now's the time to pop any questions that you have into the dialog box, and I'll take some time to cover them in the end. So what's SDM all about? Well, really it's about turning a set of seismic files on disk into an asset of data and knowledge that can save you time when you want to do something with that seismic data later on. So we convert a file system of unstructured files into a catalog and map of data containing a lot of detailed metadata and calculated information to help you QC the data. And then you've got the parameters you need just to load that data to an application and save yourself some time. As I mentioned, loading is streamlined, especially from a user perspective. We just have to search in the catalog or the map for available data, add that to a file collection, and we can load it directly to Petrel. And we also have a couple tools to condition and fix problems in the data should there be anything that we identify. The SDM also helps as a good insight into your seismic data if you have different ways of storing seismic, like different file systems or physical media, which you want to consolidate into one source. So the SDM catalog can be used to scan and hold information about data sets that are then offline or in physical storage that you then want to access later on. And with all the relevant metadata and the possibility to look at the data set on the map, it's much more useful for end users to get that information without having to load or mobilize these different storage media. So finally, some concluding remarks about the SDM. Really, what's it for? Well, it's a platform for cataloging, searching, processing, and loading of data. The nice thing about the SDM is it really keeps the data as it is. It doesn't convert or store the data in a database. It simply provides a layer on top of the data which opens up that data to loading to applications through a plugin, to GIS systems, and to further work processes in your company. The SDM creates a very extensive catalog of information about each data set. So you get the typical metadata like episodic headers, etc., but also a lot of calculated and quality control information. There's also a really good map in the SDM where you can define your additional layers, so it forms a really good basis for building a GIS system out of your seismic data or integrating seismic data into another GIS system. The SDM is also well set up to handle multi-sites and multi-locations and having a single database in the background through the ability of SDM to have different job servers in different locations feeding back to a single database. It's also worth mentioning that the SDM works with a kind of per user license, admin or read-only, so you can start small with the SDM and then build up over time, and there's not a massive overhead to get started with it. So thanks everyone for listening. I'll now take the time to go through any questions or comments that we have being submitted through the dialog box. So let's see here. Does the SDM integrate with the project tracker to identify data that's not being used in Petrel? Not right now. There's not a current method for doing that in the SDM, but it's definitely on the future plans to link with the tracker and improve the coverage there. For loading data to Petrel, can it handle 2D and 3D data? Yes, it's any data that's scanned in the SDM, so that's 2D, 3D, or pre-stack can be loaded through the plugin. So that's all the questions we have for now. If there's any ones I've missed, I can take them on email. But with that, I'll just like to say thanks very much for joining.